Hello friends, welcome to the tutorial on construction of DFA. The objective of this tutorial is to learn to construct DFA for given description. Here we will use three different cases. First is to construct a DFA for accepting strings beginning with AB over an alphabet A comma B. Another two cases will talk about divisibility test, that is the given decimal number divisible by 3 or divisible by 2. When we talk about construction of a DFA beginning with AB, all the strings belonging to this DFA or all the strings accepted by this DFA will start with AB. That means it will have first two symbols as A followed by B. Rest is, you can have anything formed out of this alphabet. So sample set is shown here. Here one can very easily see that all the strings shown here are starting with AB. So it means that if we are ensuring that the first two symbols are A followed by B, the string must be accepted. So on the input of A from Q0, we are moving to a intermediate state, say Q1, from where on the input of B we are reaching to final state. Here QF is shown as a final state. So on the input of A from Q0, machine will move to Q1. On the input of B from Q1, machine will move to QF. Rest is here that it should be accepted. A comma B, that is, let it be either input as A or B or epsilon, you must be at QF only. Here I use the word epsilon because if input is epsilon, in that case the string is nothing but A followed by B only. For the other cases may be either string beginning with B or string beginning with A followed by A. Now these are the invalid cases wherein the machine should not move to QF. So in such cases, for representing such cases, we are using here another state which is represented as a QD. That is, on Q0, if the given input is B, the transition should move to this QD. Similarly, from Q1 on the input of A, the transition should move to QD. And in QD, we are ensured that on any input, the transition should be to QD only. That means self loop on all the inputs. This self loop shown on QD will ensure that the transition will never move to QF again. Once we are at QD, that means we are at QD only. The transition is not moving outside to QD. Thus, this QD acts as a sync state. We can refer this QD as the dead state or sync state. Dead state, why? Because once we are at here, we are not moving anywhere. Sync state, why? Let it be any input. We are in QD only. Here DFA's definition is given. This DFA is having four different states, that is Q0, Q1, QF and QD. Summation is the input alphabet. Here two symbols are used in alphabet, that is A and B. Delta is a transition function. I mean, mapping Q cross summation gives Q, which means from state Q0 on the input from given alphabet, the resultant state is from Q0 or Q1 or QF or QD. That means from the finite set of states, capital Q. Q0 is the initial state and capital F is finite set of final states. Here only one final state exists, that is QF. Let's see the construction of DFA for divisibility test. We say that the number is divisible by 3 or n if the remainder is 0. So, but natural that the total number of different scenarios arising out of any given number will be n. That is, either the remainder is 0 or 1 or 2 up to n minus 1. If the remainder is a 0, we will say that the number is divisible by n, otherwise it is not. Here in this case, we are talking about divide by 3, which means the remainders will be either 0 or 1 or 2. So let's use 3 different states for representing this scenario. Say one state for representing the case when the remainder is 0, which should be shown as a final state. The another state for showing the scene when the remainder is 1. The third case is when the remainder is 2. And we'll use one state for showing initial state. So basically we require 4 different states for construction of DFA for divisibility tested by 3. The input alphabet will be, since we are talking about decimal number, the input alphabet will contain 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 10 number of symbols. Let's construct the DFA for this. Q0 is the initial state. Consider Q1 as a state when the given input is divisible by 3 and Q's remainder as a 1. Such cases are 1, 4 and 7 when the remainder is 1. Let's represent another state, the state when remainder is 2, the scenario when the remainder is 2. Such cases are 2, 5, 8 when if we divide this number by 3, the remainder is 2. Third case and most important case is the case when the remainder is 0. The symbols are 0, 3, 6 and 9. So on occurrence of any of this, we must reach to QF and declare that the input is accepted. But if the input length is more than 1, that means the decimal number ranging from 10 onwards. So for such cases, we should check that whatever number we have scanned up to, in that case, if the remainder is 0, we must move to QF. If the remainder is 1, we must move to Q1. If the remainder is 2, we must move to Q2. We'll see all these cases one by one. Here, if the input is 1, 0 or 1, 3 or 1, 6 or 1, 9, similarly 4, 0, 7, 0 and so on, the remainder is 1. So we must be available at the state when the remainder is 1, that is state Q1. 1, 1, 1, 4, 1, 7, the remainder is 2. So we have moved transition from Q1 to Q2 on the input of 1 followed by 1, 1 followed by 4, 1 followed by 7, and similar explanation can be given for 4 and 7 as well. Third case, that is 1 followed by 2, it's a 12 or 15 or 18, the remainder is 0, so we must move to final state. Similar construction can be done for Q2 and QF as well, like here 2, 0, 2, 3, 2, 6, 2, 9 stands for remainder as a 2. Here remainder as a 0. Here remainder as a 1. Similarly for QF, we have constructed for 0, 3, 6, 9 from Q0, 2, 5, 8 and 1, 4, 7. Similarly for all the inputs from Q1 and Q2 we have shown. For QF, it's time to show the inputs. If we are having 0, 3, 6, 9, it means the remainder is still 0. So we are at QF. Similar expression can be there for remainder 1 and remainder 2. So this is how we can construct divisibility tester for a decimal number divisible by 3. Here 5-tuple definition is given. The explanation can be given like we are having 10 symbols. We are having 1, 2, 3, 4 states. Only one final set, that is QF. Let's see the divisibility tester construction for divide by 2. The explanation which we can seek for finding the total number of states can be in the similar way. Like here, if we say divide by 3, that means we can have at max 2 remainders. One remainder is 0, another is 1. When the remainder is 1, it means the number is not divisible by 3. When the remainder is 0, the number is divisible by 3. So in all we require 3 number of states. 1 for representing initial state, 1 for representing the number divided by 2, the 1 and the last but for the number which is not divisible by 2. The input alphabet will be same, similar to the previous case. Q0 initial state, Q1 as a state where remainder is non-zero, and Q2 is the state when the remainder is 0. So we have shown Q2 or say QF as a final state. Here in the case we are having input as a 1, 1, 1, 3, 1, 5, 1, 7 or 1 and 9. In other words, we can say that whenever the given input is odd, we will reach to Q1. Whenever given input is even, we will reach to QF. The cases are shown here. From QF on the input of 0, we are still remaining at QF only. On 1, we are moving to Q1. Similarly, from Q1 on the input of 0, we are moving to QF. So we have ensured here that whenever the remainder is 0, we are at QF. Whenever the remainder is 1, we are at Q1. And whenever remainder is, we are at the beginning of state, we are at Q0. So this is how the DFA for divide by 2 divisibility tester can be constructed. The DFA is shown here. Here we are having Q0, Q1 and QF as a 3 state, because this Q2 need to be removed. If you have any doubts related to the construction of DFA, kindly comment on the video. I will try to ensure that the doubts are getting resolved further. Thank you very much. Have a nice time.